Let us see next the iterative in order traversal of the tree. Suppose this is the binary search tree, and along with this I am writing the addresses as well. Okay, suppose this is the binary search tree, and let me write the addresses. Addresses are randomly assumed. You can give any address that you may like. Okay, now suppose this is the binary search tree. What is the in-order traversal of it? You have to go towards the leftmost child first. Right, because it is left root right. Now what is, you go towards the leftmost child, you go towards the leftmost child, you go over here, you don't find any leftmost child. And whenever you don't find any leftmost child, you go back to the parent. After we complete it, we again go back to the parent. We again go back to the parent. That means you have to backtrack. Backtrack means go back. What do you mean by backtrack? Go back to the point from wherever it is being called. That means if you have to go back to the point from wherever it is being called, you should remember that point, right? And where do we remember that point? In stack. Why in stack? Because after 7000 we go to 2000. We do not go to the 1000. That means wherever you came just last from, you go back to that point. Therefore, we need a stack data structure. Therefore, what is the first point of the algorithm? Create an empty stack. Create an empty stack for what? Node pointers. For node pointers. And you already know what is a node pointer. It is done using linked list. And I am taking, suppose this is the stack. Now next what we do, we initialize current equal to root. We don't want to change the value of root. We say initialize current is equal to root. Therefore, what will be the value of current? The value of current will be 1000. The value of current will be 1000. Now we need to do certain set of steps. What are those certain steps of certain set of steps? We will come to know. Now what we do? We say push current to the stack. Now what is the value of current? The value of current is 1000. We have pushed to the stack. And what does the in-order traversal say? Go to the leftmost child first. Therefore, current should set to current arrow left. And what do I write over here? Current is equal to current arrow left. Now what is current arrow left? Current arrow left is 2000. Therefore, the value of current becomes 2000. Now again you need to push 2000 to the stack, right? That means these set of steps has to be repeated till we don't know the condition. We will come to know in some time. Therefore, you say push current. Current is 2000. Set current is equal to current arrow left. What is current arrow left now? It is 7000. Repeat it. Push 7000 to the stack and you say current is equal to current arrow left. Now what is current arrow left? It is null. Now, do you need to push null? No, you need to stop. Therefore, these set of steps to be repeated till current is not equal to null. Once the value of current becomes null, you need to stop the procedure. Okay, now what does it mean if the value of current becomes null and that value of current has become null by saying current equal current arrow left? That means you are going towards left and the value of current has become null. It means that you have reached the leftmost node. Since you have reached the leftmost node is at the top of the stack. Pop from the top of the stack and you print it. Therefore, after we come out of this loop, you say current is equal to pop. This is just the algorithm. Informal algorithm, formal algorithm, I will give it in some time. Current is equal to pop. What is pop? Pop is nothing but 7000. Then you print 7000 arrow data because that's the leftmost child. Therefore, you say print current arrow data. Now, what is current arrow data? Current arrow data is 3. You print 3 onto the output screen. Now, after you print 3 onto the output screen, you have to go towards the left child and you have to process the same steps again. Therefore, what do we write? I say current is equal to current arrow right. What do I write? Current is equal to current arrow right. Now, what is 7000 arrow right? It is 6000. Now again from 6000 you need to do the in-order traversal of the tree, because it may have the left child, it may have the right child and all. Okay. Therefore, what we do, again we repeat these steps. Therefore, from this point, again you go back over here. That means these things have to be repeated, and whatever has to be repeated has to be put in a what? Body of the loop. Now, therefore, as of now, I write here while, and we don't know the body of the loop. We will see it in the some time. Now, what do you say? Push current, and you say current equal current arrow left till the value of current is not null. That means these steps has to be repeated till what? Current is not equal to null. Therefore, I can write while current is not equal to null, do this procedure. Okay, that is what this statement means, while current. Now, what is the value of current? 6000. Push 6000 and set current equal to current arrow left. Now, what is current arrow left? Null. Go back, null is false. You come out, you say current equal to pop. What do you pop? You pop 6000 from the stack. This is gone. You print 6000 arrow data. What is 6000 arrow data? 4. 4 is printed on the output screen, and you say current equal current arrow right. 6000 arrow right is what? Null. Okay, go back. Are we stopping the procedure? No. It means if the value of current is null, do not stop. Do not stop as of now. Again, you come here. Assume that this condition is true. Come here, while current is false, do not execute this. Again you say current equal to pop. What do you pop? You pop 2000 from the stack, and you print 2000 arrow data. What is 2000 arrow data? 5. And you say current equal current arrow right. What is 2000 arrow right? 5000. Go back. Assume that the outer while loop is true. While 5000 it is true, push 5000 onto the stack. You have pushed 5000 onto the stack, and you say current equal to current arrow left. What is 5000 arrow left? 5000 arrow left is null. Go back, null is false, you come out, current equal to pop. What do you pop? You pop 5000 from the stack. Okay, after you pop 5000 from the stack, print 5000 arrow data. What is 5000 arrow data? 6. And you say current equal current arrow right. What is current arrow right? Current arrow right is null. Go back, assume the outer while loop is true. That means if the current is null, we need to still process. Okay, while current is false again, you come out, you say current equal to pop. What do you pop? You pop 1000 from the stack. You print 1000 arrow data. Now what is 1000 arrow data? It is 10 is printed. You say current equal current arrow right. What is 1000 arrow right? It is 3000. Go back. Assume the condition is true. That means if the current is not null, I have to process the condition. If the current is null, also I have to process the condition. Let's see what is the final condition. While 3000 it is true, push 3000 onto the stack. You say current equal current arrow left. What is 3000 arrow left? It is null. Go back, null is false. Current equal to pop. You pop 3000 from the stack. You print 3000 arrow data. What is 3000 arrow data? 25. And you say current equal current arrow right. Go to the right child. Therefore the value of current becomes 4000. Now see here, the value of current is not null. Still we are processing. And you say while current, print push the current. What is the value of current? The value of current is 4000, and you say current equal current arrow left. It is null. Go back, null is false. You say current equal to pop. You pop 4000. You print 4000 arrow data. What is 4000 arrow data? 27, and you say current equal current arrow right. What is 4000 arrow right? Null. Now this is the point where I need to stop. When I stop, when the value of current becomes null as well as stack becomes empty, both should be false, then only you stop. If one is false, you do not stop. Current was becoming null. Did we stop? No. In the meantime, stack has also become empty, but current was not empty. Did we stop? No. We stopped only when the current has become null and the stack has become empty. That means both should be false. And if both should be false, then only we stop. That means we have to use OR condition. Therefore, we say while not stack empty or current not equal to null, process it. Now, not empty stack, it is false. Current not equal to null, it is false. You stop the procedure and you see that this is the iterative in order traversal of the tree. Please copy down this algorithm. Then we will see how do we write the code for it. Thank you. Let us write the code for iterative in order. What is the first step of the algorithm? Create an empty stack. Therefore, we say struct stack yes. and stack will be created, but it is not empty. You have to initialize the stack. Hence we say init stack of ampersand yes. Now this is the stack that is being created. This is yes, null. Let the address of this be say 23,000. You can assume any address that you like. Now what we have to do, initialize the current is equal to root. Therefore what do I write over here? I say struct node star current is equal to root. Hence the value of current will become equal to what? 1000. The next step of the algorithm is while not is empty of stack. Already we have written this function, while not is empty of stack or current not equal to null. Now this is the stack. Stack is empty, not is empty is false, or current. What is the value of current? 1000. It is true. False or true is true. Therefore you have to execute the while loop. Now what do we say? We say while current is not equal to null. Yes, current is not equal to null. Push the current and set current equal current arrow left. And what do we write over here? We say push ampersand yes comma current, and current is equal current arrow left. Now when you push current, what is the value of current? The value of current is 1000, and you say current equal current arrow left. It is 2000. Go back. While current is true, push 2000 onto the stack, and again you say current equal current arrow left. Now current arrow left will become 7000. Go back. 7000 is true. Push 7000 onto the stack, and you say current equal current arrow left. What is 7000 arrow left? It is null. Go back. It is null. Now whenever it is null, we have reached the leftmost child. You have to pop an item from the stack. Hence we say E is equal to pop of ampersand yes. And what should be the type of E? It should be struct node star E. Okay. Now when you pop, what is going to be popped? The popped item is 7000. Now you have to print 7000 arrow data. How do you print 7000 arrow data? You say printf %d E arrow data. Okay. Okay, or you can say current itself, right? Let it be. E is equal to 7000 arrow data. Therefore 3 will be printed. Now set current is equal to E arrow right. Okay. Current is equal to E arrow right. Now what is E 7000? 7000 arrow right is null. Therefore the value of current becomes null. Go back. Not is empty stack. If the stack is not empty, therefore continue while current. The value of current is null. Therefore do not execute this. E is equal to pop. What do you pop? You pop 2000. Print 2000 arrow data. What is 2000 arrow data? It is 5. Current is equal to E arrow right. 2000 arrow right. It is 5000. Is that okay? Go back. Not is empty stack. If the stack is not empty, while current, yes, 5000 is true. Push 5000 onto the stack and set current is equal to current arrow left. What is current arrow left? Null. Go back. While null is false, do not execute this. E is equal to pop. What do you pop? You pop 5000. Print 5000 arrow data, which is 6, and set current is equal to E arrow right. 5000 arrow right is null. Go back. While not is empty stack, yes. While current, the condition is false. E is equal to pop. What do you pop? You pop 1000 from the stack. Print 1000 arrow data, which is 10, and you say current is equal to E arrow right. Okay, sorry. E is 1000. 1000 arrow right. What is 1000 arrow right? It is 3000. Go back. Not is empty stack. The condition is false. But current is not null. The condition is true. While current, the condition is true. Push current onto the stack. What is the value of current? 3000, and you say current is equal to current arrow left. That is null. While null, the condition is false. E is equal to pop. What do you pop? 3000. Print 3000 arrow data 25, and you say current is equal to E arrow right. 3000 arrow right is null. This is being also popped. Go back. Not is empty stack. The condition is false. Current is null. The condition is false. False or false is false. You come out and you stop the procedure. This you see the iterative in order traversal of the tree. Now let's see the iterative post order traversal of the tree, and I will say the algorithm as well. Thank you. Let us see the iterative post order. Let me explain the algorithm first. What is post order traversal of the tree? You have to process the left child, the right child, and then the root. Is that okay? The post order traversal of this tree is 2, 4, 3, 6, 5, 27, 25 and 10. That's the post order traversal of the tree. And it is again the depth of first search algorithm. Therefore, we need the stack data structure. Now, what we need to do again over here, I have to go towards the leftmost child first. I need the stack. Therefore, the first step of the algorithm is create an empty stack. Now, for what? For node pointers. Right, there is a node stack created. I do not want to change the value of root. Never do that because we might need that later. The best and the foremost thing is you have to initialize current is equal to root. Therefore, the value of current becomes equal to 1000. What is the condition? We don't know the condition something till what we have to process as we did in order traversal, but we will do some things. Now what we have to do, we will check does the current has any right child. Why we have to check if the current has right child? Because after we process the left tree, we have to process the right subtree also, right? Before I process the root, I have to process the right subtree. Therefore, what do I say? Push root current right child. Push current arrow right if any. Push current arrow right if any. What is 1000 arrow right? 3000. Yes, it is there. Push it. And then what you have to do? You have to push the current onto the stack as well. And what is the next step I say? I say push current onto the stack. What is the value of current? The value of current is 1000. Push 1000 onto the stack. And this, did we reach the leftmost child? No. Go to the left child then. And how do we go to the left child? We say current is equal to current arrow left. We say current is equal to current arrow left. Now, what is 1000 arrow left? 1000 arrow left is 2000. Now, these steps has to be repeated, whatever I put in box. Now, whatever has to be repeated has to be put in the body of loop. Therefore, I write here while. We don't know the condition. And let me put in the body of loop now. Okay. Assume the condition is true. Push current arrow right if any. What is 2000 arrow right? It is 5000. 5000 is there. Therefore, you push it. Then you push current to the stack. And you say current equal current arrow left. What is current arrow left? It is 7000. Go back, assume the condition is true. Push 7000 arrow right if any. What is 7000 arrow right? 6000. And push the current to the stack and set current is equal to current arrow left. What is current arrow left? 9000. Again assume the condition is true. Push 9000 arrow right if any. Now is there any 9000 arrow right? No. Push current onto the stack and set current is equal to current arrow left. Now what is current arrow left? Null. Whenever you reach null, okay, let me take one more, okay, let it be. Now whenever you reach null, that means you have reached the leftmost node. Now after you reach the leftmost node, you have to pop an item from the stack. And how do you pop an item from the stack? You say E is equal to pop. Now when I say E is equal to pop, the value of E will become what? 9000. You can take any other variable name as well. Now you have to check, is the popped item has the right child? Why? Because 9000 is the root for us. Is there any right child? If there is any right child, you have to process the right child first. Therefore, what do we write? If E arrow right is not equal to null, then we have to process something. Now, as of now, what is the value of E arrow right? 9000 arrow right is null. Therefore, do not process this. Therefore, hence, we execute what? We execute the else block. And that means this is the leftmost node which do not have the right child. That means it is a leaf node. That's okay, right? It is the leftmost node. Leftmost node means it do not have left child by the definition, and it do not have the right child as well. That means it is a leaf node which has to be printed first in the post order traversal of the tree. And what do we do over here? We say print E arrow data. Okay, or you can even say current equal to pop itself. Okay, why use another variable? You say current equal to pop, the value of current will become 9000. Okay. Then what do we say? We say current arrow data, because in live class I have taken the same variable name. I don't want you to confuse. 9000 arrow data is 2. You print 2. Now as soon as you print, the value of current has to be initialized to null. Why it has to be initialized to null? I will say when the value of current is null, this condition is while current is not null. If the value of current is null, you do not do anything. You pop an item from the stack. Why we pop an item from the stack? Because for these two, left child, right child, and the root is done. Therefore, you have to pop the next item from the stack. Hence, these steps has to be repeated again. Hence, I say while. Again, I don't know the condition. Go back, assume the condition is true. While current, the value of current is null, because we have set current equal to null. Current is false, do not execute this. Current equal to pop. What do you pop? You pop 7000 from the stack. Now, you check 7000 arrow right. What is 7000 arrow right? 6000. Yes, it is available. That means, before you process 3, you have to process the right child. We have to say, the root, boss, you please wait. We have the right child. We have to process the right child. Then I will come back to you. Now, if current arrow right is not equal to null, yes, it is not equal to null, and the right child is available at the top of the stack. That means it has to be still processed. And how do we say? We say peak of ampersand, yes, is equal current arrow right. Okay, now what is peak of ampersand? Yes, it is 6000. 7000 arrow right is 6000. 6000 equal to 6000. Yes, it is available at the top of the stack. Therefore, what we do? We pop this right child from the stack. What we do? We pop the right child from the stack. Because right child should come before the left child. Before the root. Then we push the root to the stack. Then what do we say? We say push ampersand, yes, comma current. Now what is the value of current? The value of current is 7000. And since this child has to be processed, we say current is equal to current arrow right. What do we say? Current equals current arrow right. Therefore the value of current will become 6000. Since if has executed, else should not execute. Go back, assume the condition is true. While 6000, the condition is true. 6000 arrow right, it is null. Therefore, don't do anything. Push 6000 back to the stack. And if you see, 6000 and 7000 are swapped. Is that okay? And you say current equal current arrow left. 6000 arrow left is null. Go back, current is null. Do not execute anything. Current equal to pop. What do you pop? You pop 6000 from the stack. Okay. 6000 arrow right, it is null. Null not equal null is false. Do not execute this. Print current arrow data. 6000 arrow data is 4. 4 is printed. Set current equal to null. Current becomes null. Go back, assume the condition is true. Current is null. Do not execute anything. You come out, you say current equal to pop. What do you pop? You pop 7000 from the stack. Is that okay? 7000 arrow right not equal to null? Yes, it is not equal to null. That means it has right child. Did we complete the right child? Yes, we have completed the right child. And how do we know that we have completed the right child? Because right child is not available at the top of the stack. Now peak of ampersand is 2000. 7000 arrow right is 6000. Is 2000 equal 6000? The condition is false. Do not execute this. You print current arrow data. 7000 arrow data is 3. And you set current is equal to null. Go back, assume the condition is true. Current is null. Do not execute it. You come out, you say current equal to pop. What do you pop? You pop 2000. Okay. Now check here. 2000 arrow right not equal to null? Yes, it is not equal to null. Peak of ampersand is 5000. Current arrow right is also 5000. That means right child is available at the top of the stack. We still did not process the right child. Therefore, you pop it, you push the current, and you say current equal to current arrow right. 2000 arrow right is what? 5000. Do not execute the else part. Go back. Assume the condition is true. While current is 5000, it is true. Push current arrow right if any. Is there any 5000 arrow right? No. Then you have to push the current. What is the value of current? The value of current is 5000. And you say current equal current arrow left. Current arrow left is null. Go back. The condition is false. You come out. You say current equal to pop. What do you pop? You pop 5000 from the stack. Now you check. 5000 arrow right. Null not equal null is false. You come out, you say print current arrow data, 5000 arrow data is 6, and you set current is equal to null. Go back, assume the condition is true. While current is null, you come out, current equal to pop. What do you pop? You pop 2000 from the stack. Okay, 2000 arrow right not equal to null? Yes. Did we process the right child? Yes. How do we know that we have processed the right child? Because right child is not available at the top of the stack. Peak of ampersand is 1000. Current arrow right, 2000 arrow right is 5000, is 1000 equal to 5000, the condition is false. We say print current arrow data, 2000 arrow data is 5. You set current to null. Again assume the condition is true while current is false. You do not execute this. Current equal to pop. What do you pop? You pop 1000. Okay, now again you check. Current arrow right, 1000 arrow right is 3000, not equal to null. Yes. Peak of ampersand s is 3000. Current arrow right is also 3000. 3000 equal to 3000. Yes. Yes. You say pop this, push 1000, set current is equal to current arrow right. What is current arrow right? It is 3000. Since if has executed, it should not execute. Go back. Assume the condition is true. While current it is true. 3000. Push right child if any. Yes, there is right child. It is 8000. Push 3000 onto the stack and set current equal to current arrow left, which is null. Go back. Null is false. You come on. You say current equal to pop. What is pop? You get 3000. Okay. Now you check. 3000 arrow right not equal to null. Yes, it is not equal to null. Peak of ampersand s is 8000. Current arrow right is also 8000. 8000 equal to 8000 is true. Therefore, you pop, you push the current and you set current is equal to current arrow right. It is 8000. Go back, assume the outer while is true, while 8000 is true. Push current right child. There is no right child. Push the current to the stack. That is 8000. Current equal current arrow left. The condition is false. Go back, the condition is false. You say current equal to pop. What do you get? You get 8000. Print 8000. Sorry. Current arrow right. What is 8000 arrow right? Null. Null not equal null is false. You come out. Print 8000 arrow data. What is 8000 arrow data? 27. Set current equal to null. Again assume that the condition is true. That means even if the current is null, we have to still process it. Current is null. You come out. Current equal to pop. What do you pop? You pop 3000 from the stack. Is that okay? Current arrow right, 3000 arrow right is 8000, not equal to null. Peak of ampersand s is 1000. 1000 equal 8000 is false. Therefore, do not execute this. Print current arrow data. 3000 arrow data is 25. Set current is equal to 9. Go back. Again, assume the condition is true. While current is null, the condition is false. You come out. Current equal to pop. What is pop? 1000. Current arrow right. What is current arrow right? 3000, not equal to null. The condition is true. Peak of ampersand s. Is there any peak? No. Therefore, the other condition you check is not is empty of stack. While the stack is not empty, the condition is false. You come out. You print current arrow data. 1000 arrow data is 10. You set current equal to null. Go back. You have to stop it. When you stop, when current becomes null and the stack becomes empty, both. Therefore, we say stack not empty or current not equal to null. You stop the procedure and this becomes the iterative post-order traversal of the tree. I want you to try yourself writing the code for the iterative post-order. And in the next class, we will continue with the many more programs. Thank you.